We've now finished the basis of refraction and we're moving into converging and diverging lenses, which is in chapter 13. So your references are section 13.1 and 13.3 for converging and diverging lenses. That's your title. Moving on to the next slide. So what we see are a drawing on the left and an actual example of a converging lens on the right. And both are attempting to show that parallel rays, when they pass through a converging lens, will meet at some point. So, a lens that is thicker in the middle describes a converging lens and will cause incident rays to converge after passing through the lens, which is again refraction. So that's our converging lens. Moving on to diverging lenses. A diverging lens, this time around, we see the diagram drawn on the left and the real model on the right, and this time the rays do not come together like they did the last time, they spread out. Diverging lens is a lens that is thinner in the middle and will cause incident rays to diverge or spread out after they pass through the lens, so this is still refraction. Moving on to our next slide. Some common terms which have the same basic meaning as they did for mirrors. First, we have converging, meaning light rays come together, and diverging, meaning light rays spread apart. Exactly the same as we had for mirrors. The principal axis is exactly the same. It's a line meeting, in this case, it'll be a lens perpendicular to that lens. We have a focal point, which is where rays will come together. We have a focal length, which is the distance from the focal point. Instead of being to the vertex on a mirror, it will be to the corresponding point on a lens, which we'll describe in a moment. So these terms are all common from our mirrors. Moving on to the next slide, which has the new terms. New terms. First of all, optical center is the center of the lens. This corresponds to the vertex. However, this is actually physically in the middle of the lens, as opposed to a single point somewhere on the mirror. We also have something called a center line. A center line runs perpendicular to the principal axis, and it has to pass through O, the optical center. And we're going to be using this this line to simplify the location of drawing refractions. We'll get to that in the next slide. Also new, we have something called a secondary focal point, which is F with a little apostrophe up high. We refer to it as F prime. And this is the focal length, again away from the optical center, but now it's going to be on the opposite side of the lens from F. This acknowledges that light can travel through a lens both ways, and so there'll be a focal point on both sides of a lens. Lastly, we have two corresponding terms, 2f and 2f prime. These again are points on the principal axis. Again, the distance f, the focal length, away from the corresponding points of f and f prime, and we use them for identifying locations of either objects or images, much the same way that we used c or f in mirrors. So those are the new terms. Moving on to this idea of the simplified location for drawing when we talked about the center line. So let's talk about the true path. So in a real lens, we will find refraction happening both here when light travels from air into that lens, and again as light leaves that lens going out into air again. What we find is that we can approximate the two of them put together as one point if we approximate it on that center line. We approximate the path that the light ray will travel in the lens to simplify the problems. So instead of drawing two bends, which is the actual path, we just draw one. Let's see how this looks in a real lens. This diagram you're going to find in your textbook on page 552 on converging lens. So let's put all these things together. Principal axis running horizontally, optical center has now replaced the vertex. If we position an object, which I will draw on the left-hand side here, because light rays will leave an object, travel through a lens, and if they happen to be parallel, they will all come together at a focal point, which is F. The secondary focal point you'll find on the left-hand side, close to the object, because that's where it has to be, because the principal focus is on the right. If we needed to label our 2F and 2F prime, we would simply measure this distance here. That would be F. We go the same distance here and mark this as 2F. And in the same way, we'd estimate 2F prime. I'm just going to estimate it, but visually it would be about there. We'd measure again and find what it is on the right side, or the left side, sorry. Last slide. This time we have a diverging lens, and again the object is placed on the left. Rays travel, strike the lens. They diverge this time, so they spread out, moving away from the principal axis, and we will find these ray extensions going off to the left to where the principal focus is, and then on the opposite side we'll find our secondary principal focus, and that defines where the focal point and secondary focus are. Optical center is right in the middle of the lens. That gives us all of our new terms, and we will be having a look at how we use these to locate images in class. Thanks for watching.